Assalamu alaikum everyone. This is lecture 17 on control system engineering 1. We are discussing chapter 6, stability. So basically the basic condition of the Routh Hurwitz criterion is already been discussed. Now there was two special cases as we are discussing at the end of the last class. Those two will be trying to cover in this class. So basically, the first case was case one. Two special cases we had. The case one was if zero appears in the first column, then what happens? So zero on the first column. Okay, so there is two methods to resolve this problem. The first one is assuming a very small number epsilon, which is just slightly higher or slightly lower than zero. This is one method, and the other method that we discussed is reversing the order of the coefficient. Reversing the order of the coefficients. Okay. So let's see both of them together. So in the example, the first method is been discussing example 6.1. So let us start with the example 6.1. Sorry, 6.2. Example 6.2. So here, transfer function, closed loop transfer function is given. T of s equal to 10 by s to the power 5 plus 2 s to the power 4 plus 3 s cubed plus 6 s squared plus 5s plus 3. Okay, so now the highest order is to the power 5. So start forming the table. So s to the power 5, s to the power 4, s cubed, s squared, s to the power 1, s to the power 0. So separate the lines for ease of manipulation. Okay, so now placing the coefficients. So zigzag pattern as we have discussed, 1, 2, then 3, 6, 5, 3. Okay, so zigzag pattern as we have discussed in the last class, something like this. Here, 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 here. This is the way of placing the coefficients. Okay, next is basically filling up the rest of the table. So the format was something like this, forming calculation based on forming 8, that is multiply these two, then subtract the multiplication of these two, then divide by this one. So 6 minus 6, that is 0 is coming. Then we have now for bigger 8, the first 2 will be always there. So bigger 8 is 5 into 2, that is 10 minus 3, that is 7, 7 divided by 2. Okay. So 7 divided by 2. Now as the 0 appears, we cannot take the 0, so rather we take a very small number, very close to 0, epsilon. So now we have to form the continue the table again. So now you have to multiply this one, and this one, and divide by this one. So basically 6e minus 7 into 7 by 2, 2 into 7 by 2, so basically 7 divided by epsilon. So this first parameter here will be 6 epsilon minus 7 divided by epsilon. Then since 0 is here, now if you multiply epsilon into 3 minus 0 divided by epsilon. So basically 3 epsilon will be cancelled, 3 will be coming here. So directly this parameter is coming here. Okay, next formation of the table again. So these two has to be multiplied, then these two has to be multiplied and subtracted, then divided by this one. So basically 6 epsilon 6 epsilon minus 7 divided by epsilon into 7 by 2 minus 3 epsilon divided by the 6 epsilon minus 7 by epsilon. So if you multiply these two, then we have actually 42 epsilon minus 49. And then if you take 2 epsilon common, 2 epsilon, then minus 6 epsilon square. Okay, and the denominator will be something like this. 6 epsilon minus 7 divided by epsilon. So basically epsilon will cancel out, and this two will be multiplied by this parameter. So ultimately what we are going to get 42 epsilon minus 49 minus 6 epsilon squared divided by 12 epsilon minus 40. Okay, so since this parameter is 0, so 0 is going to appear here, and 0 is also here. So now if you try to form the table again, so 3 into that minus 0 divided by this big quantity, so this will ultimately 3 is going to come here. So once you have a 0 here, automatically this parameter goes to the adjacent column. So now, as we have said, that we are assuming a very small number, which is very close to 0. Okay, so now we have to actually construct another table or the side by table, because this one become a bit clumsy. So say the first column is basically the 1, 2, then epsilon, then 6 epsilon minus 7 divided by epsilon. Then you have 42 epsilon minus 49 minus 6 epsilon squared divided by 12 epsilon minus 40. Finally 3. Now we have to find out the sign of this first column. So to find out the sign, these two cases we are going to consider. The first case one is epsilon equal to 0 plus, very close to 0, but a number positive number. And then you have epsilon equal to 0 minus, very close to 0, but a negative number. So now this first one is positive sign, second one is positive as well. Now third one, based on the value of the epsilon, because epsilon itself is positive, but very close to 0. So if it is very close to 0, then 6 into very close to 0 will be almost 0. So minus 7 divided by something positive. Okay, so basically it will give you minus 7 divided by plus any number, it will actually the sign will be minus. And next one here, what will be the sign? Again, something multiplied by very close to 0 is 0. So 42 epsilon is 0, 6 epsilon is 0, 12 epsilon, 12 epsilon is also 0. So basically minus 49 will be divided by minus 14. So this is minus divided by minus is plus. And the last one is plus. So what is our conclusion? Is basically there is a 2 sign change here. Okay, so because of the 2 sign change, 2 pole is on the right half plane. So basically our system is unstable. So this is in the conclusion that we obtain if we take 0 epsilon equal to 0 plus. So 2 pole on right half plane. Any pole in the right half plane is enough for your system to be unstable, but we have 2 of them, so there's really no question about it. The system is unstable. Now, if we take another one 0 minus, then this one is plus, because the constant plus. Sorry, epsilon is now negative, so we have a negative sign here. Then we have this quantity. What will be happening in this quantity? 6 is 0 because E is very small number. So this is almost 0. Minus 7 divided by minus something. So minus divided by minus is basically plus. And then here as well, this one very close to 0. So these are cancelled. So minus 14 divided by minus 14. So this is also plus. And third, last one is also plus. Again, as you can see, there is two cases, basically, two sign change. So the same result we obtain even if a is equal to 0 minus. Okay, so system is basically a unstable one. We have two poles in the right hand plane, because of which the system is unstable. Now, case next one with the same example. Next, what we can do is we can change the coefficient. So the second, next one, where the characteristic is this one. So basically, if we alter the coefficient, so now this one will have the highest coefficient of the highest order, which is s to the power 5. So basically 3 s to the power 5 plus 5 s to the power 4 plus 6 s cubed plus 3 s squared plus 2s plus 1. So we have just taken the coefficients in the reverse order. As we have said, s equal to 1 by d can be assumed, and we are in the equation, and this is what we are going to get. So still the order of the equation remains same. So basically s to the power 5, s to the power 4, s to the s cubed, s squared, s to the power 1, s to the power 0. Now the coefficients, it's always better to draw the lines. Okay, so fill up the table with the coefficients. So basically this is 3, 5, 6, 3, 2, 1. Now, if you multiply again from the table, so if you multiply then 5 into 6, 30 minus 9, that is 21 divided by 5. So 21 divided by 5. Then 5 into 2, that is 10 minus 3. So 7 divided by 5. So as you can see, the 5 is common, 1 by 5 is common. So both of them can be multiplied by 5. So multiplied by 5. Also multiplied by 5, and as well as divided by 7. Okay, so divided by 7. So what we are going to get here is basically 3, and we are going to get here 1. Okay, so if you want, this one can also be replaced by 0. So basically, 3 into 3, again, is formed at 8. So 3 into 3 is 9 minus 1. 9 minus 5, basically 4 divided by 3. So 4 divided by 3. And then this one will be 3 to 1 minus 0 divided by 3. So basically 1 will become here. Again, if you want, you can multiply this equation by 3. Then what we are going to get here is you can replace this by 4. You can replace this by 3. Okay, so 4 minus 9. So basically minus 5 divided by 4. So minus 5 divided by 4. Then 0. So this 3 directly coming here. Now, if you just observe the sign changes, as you can see, if you reverse the order, still you have two sign changes from plus to minus, then again from minus to plus. So the 3 should be there. Okay, so as you can see, the result is unchanged. The system is still unstable because of the two pole which is on the right half plane. So this was your case 1. Now the case 2, basically what you have is case 2. Now entire row is 0. So entire row becomes 0. So why this one thing happens? Because the polynomial or the characteristic distribution that we have, that polynomial actually contains even polynomials. Because of that even polynomial, one row, one entire row can become 0. So let us go with one example, then we'll actually illustrate a bit about the even polynomial and what are the possible solutions that we have. So example 6.4, example 6.4. So closed inlet transfer function is provided, 10 divided by s to the power 5 plus 7 s to the power 4 plus 6 s cubed plus 42 s squared plus 8s plus 56. So again, fifth order equation. So s to the power 5, s to the power 4, s to the s cubed, s squared, s to the power 1, s to the power 0. Okay, now place coefficients 1, 7, 6, 42, 8, 56. So look at this column, this row. Actually, this row can be divided by 7. So 1, 6, 8. Now, two identical columns. So 6 minus 6 is 0 divided by 1. 8 minus 8, 0. So basically, the next column is becoming 0, 0. And if nothing is there, it can be replaced by 0. So all 0 is becoming. So it's difficult to proceed further with the calculation. So whatever the procedure is, whenever you have a 0, so the column before that, whatever the coefficient you have, that is what is called even polynomial PS equal to uh, s to the power 4 plus 6 s squared plus 8. Okay, so this is the coefficient of s to the power 4. This is the coefficient of s squared, and this is the coefficient of a constant, just coefficient. Why? Because of the fact that this is the coefficient of s to the power 4. This is the coefficient of s to the power 3. Then this is 2. This is 1. This is s to the power 0. So zigzag way we put in that way. So that is why even equation, even polynomial equation looks like. So the procedure is very simple. So you differentiate the even polynomial equation with respect to s and find out the result, which is 4s cubed plus 12s squared plus 0. So now this coefficient will be replacing the 0, that is 4, 12, 0. And now again, as you can see, it can be further divided by 4. So actually it will be 1, 3, and this is 0. So now, after doing that, you can you go for completion of the table. So now it is 6 minus 3, okay, divided by 1. So basically 3, then 8 minus 0 divided by, so basically it will be 8 will be coming straight away. So once you have a 0, this parameter directly comes in that way. Okay, now next is basically 9 minus 8 divided by 3. 9 minus 8 is 1 divided by 3, so 1 by 3. And there is 0, so 0 will be here. Now, because of this 0, this will be also going here. So what we are getting here is basically the entire row is 0. So it gives us two portions of the polynomial. So one polynomial, one portion is from where actually the even polynomial is started. So based on which equation. So we have one portion of this table here and the other portion is there. So this portion downwards is even polynomial portion, even polynomial portion, and the upward one is other portion, the left of the portion. So we have to analyze this, we have to make the analysis, and both the analysis differently. Okay. Now the question is whether this system is stable or unstable. What is the interpretation, the meaning of the interpretation of the entire row 0? So for that we have to know two things. So one thing is even polynomial is symmetrical about the origin. Okay, so even Okay, so even polynomial is symmetrical about the origin. So what does it mean? There is three possible cases there. Number one, they can be symmetrical and real. Roots symmetrical and real. This is one thing. Then roots symmetrical and imaginary. And the roots are quadrantal. Okay, so roots uh, quadrantal. Okay, what is mean by this? So figure wise, so if you have something like this, geometric axis, real axis. So the first one means if you have one root here, you have another root here. Okay, so this is symmetrical about the origin. Both of them are real. So this is one case one. So this is both of them are prime. Next one is symmetrical and imaginary. So if one is here, so other one is here. So equidistance. So complex conjugate. So this is what is called the second one. And the third one is quadrantal. So quadrantal, what is means? You will have equidistance in 4 coordinates. So this is something what is called a quadrantal. So basically, if you draw the lines, they'll be on the same line. Okay. So C, how to say which is C prime, C prime, C double prime, something like this. Okay, so this is quadrantal. So this is the only 3 possible cases. Okay, now evaluate which one of the 3 is happening in this case. So first of all, there is no sign change in the other zone. So here there is no sign change. So basically, there is only one. There is only one. There is no sign change. So it's stable. So it is on the left side. So no question about it. Now, what about the even polynomial? In the even polynomial, there is only 3 cases possible. So in 2 of the cases, the roots will be in the right hand plane. So in B and C, sorry, in A and C, basically in A, as you can see, one pole is in the right, one pole is in the left. So this is one case. And because of which the system will be actually unstable. Okay, so that means if you have this condition A, then there should be at least one sign change. Okay, so this is one thing. And in the C as well, in the C, what happens? 2 of the poles are actually in the right hand plane. Even if you guess that thing happening, there should be 2 sign change in the even polynomial. But in our case, as you can see, in the even polynomial, there is no sign change. All of them are actually positive in the even polynomial. So what does it mean? 4 of the pole is there, no question about it. So in the even polynomial, we have 4 pole. In the other, we have only 1 pole. And in the even polynomial, all poles are on the geometry axis. So maybe, just maybe, 2 here, 2 here, and 2 somewhere here. So, but always remember one thing: if in case of the poles in the geometry axis, if 2 of the pole is on the same location, okay, then the system is also unstable because of the fact that then there will be t introduced in your solution, minus j omega t. So that t, as time approaches infinity, this quantity will also be then will be approaching infinity. Okay, so that is what system is unstable. So whenever this type of scenario is occurring, we also have to check whether the poles are in the same location or not. So multiplicity of 1 is acceptable. The multiplicity of more than 1 of the poles is not acceptable. That will make the system unstable. Okay, now we'll look at another example related to this one, example 6.5. 6.5. Now, again, a closed loop transfer function is provided. Yes, equal to 20 by s to the power 8 plus s to the power 7 plus 12 s to the power 6 plus 22 s to the power 5 plus 39 s to the power 4 plus 59 s cubed plus 48 s squared plus 38s plus 20. Okay, again, it's a bigger polynomial. Even bigger polynomial is very difficult to find out the roots. That is why actually we go for the Routh table, which just give us the number of the pole for which the system is unstable, but the exact location is not been figured out. So let's try to solve this one. S to the power 8, s to the power 7, s to the power 6, s to the power 5, s to the power 4, s cubed, s squared, s to the power 1, s to the power 0. So okay, so next is fill up the table. The table is basically 1, 1, 1, 12, 22, 39, 59, 48, 38, and 20. So now, again, the 8 thing you fill up from the 8. So 12 minus 20 is 2. That is 10 divided by 1 is 10. And 39 by minus 59. So this, sorry, 12 minus 20 minus 10. So 39 minus 15, that is minus 20. Then 48 minus 38 is 10. Then the 20, because there is a current here, 20 will be current there as well. So as you can see, this row is multiplicity of 10. So basically you can divide it by 10. So this is 1, sorry, minus 1. This is minus 2, 1, 2. So again, now from the table, minus 22 plus 2 basically is minus 20 divided by minus 1. So 20 minus minus cancelling each other. Then we have 16 minus 59 minus 1 is 6 minus 60 divided by minus 1. So basically 60. Then next one is minus, we're just following the 8. So minus 38 divided by minus 2, that is minus 40 divided by minus 1. So basically 40. Again, as you can see, this one is a multiplicity of 20. And so basically it can be divided by 20. So 1, 3, 2. You can use it, or you can just use a calculator. But if the number is smaller, you can do the calculation without using the calculators. So minus 2 minus 3, that is 1. Okay, so minus 2 plus 3, 1 divided by 1. So this is only 1 will be coming here. Then you have 1 plus 2, that is 3 will be coming here. This 2 will be going there as well. So now you have 1, 3, 2, 1, 3, 2. So basically, definitely, if you know 3 minus 3 is 0, 2 minus 2 is 0. So you can also replace it with 0. So now you have reached the condition of entirely 0 row. So this one will be our auxiliary equation. So basically P of S equal to S to the power 4 plus 3 SS square plus 2. Now dPS by ds is basically 4s cubed plus 6s squared plus 0. So now replace this by 3, sorry, 4, this one by 6, and this to 0. Again, this can be divided by 2, so 2, 3, 0. So now 6 minus 3, that is 3 by 2. Okay, and then also 2 will be coming directly here. So now you can multiply, if you want, you can multiply this equation by 2, this column by a row by 2. So basically it will be 3 and 4. Okay, so now 3 into 3, 9 minus 8, basically 9 minus 8 is 1 by 3 and 0. And basically this 4 will be going there. So what is our conclusion here? So again, we have to separate it into two. So this is one portion, that is even polynomial, and other portion of the equation. So in the even polynomial, we have 4. In the other polynomial, we have 4 poles. So 4 poles in the even polynomial, 4 poles in the other polynomial. Now, which case is appearing? Now, as you can see, in the even polynomial, is there any sign change? So even polynomial, all of them are positive. Okay, so there is no sign change. So what does it mean? We know that 3 cases available is either this, or this. So as you can see, this is not an option. So this is not an option. This is not an option. This is not an option. So only the fact is that is available is we have 2 cases of j omega. Okay, so we are just analyzing. So we have to form a table. So location. Okay, location is right half plane, left half plane, and j omega axis. Okay. And even polynomial, 4 poles, and other 4 poles. Okay. So now. Okay, so in the even polynomial, we already calculated that there is no sign change. So there is 2 possibilities. So only possibility is we have combination of 2 roots, something like this. Okay, so 4 poles all in the j omega axis. So there is no pole here. Also, we can actually find out another one total. And in the other, what you can see in the other portion, as you can see, from 1 to -1, there is one change. The -1 to 1, there is another sign change. So basically, 2 of them in the left hand plane and 2 of them in the right hand plane. So this is coming here. So there is no even polynomial in the left or right. So basically, total is 2, 2, 4. So total number of the pole is 8. So this is how you have to find out which one of the cases happening within. So in the book, there is some additional examples. Let us start those. So example 6. This method is very straightforward and simple. There is nothing complicated here. So now example 6.6, we are using a closed loop system. And we need to fit that closed loop system. Something like this. So 200 divided by s into s cubed plus 6s squared plus 11s plus 6. If we fit that in the corresponding signals, cs, rs plus minus es. So now, what thing you have to do? First thing you should do is form the ps. Ps equal to gs, forward path gain, plus 1 plus forward path gain. So basically 200 by s into so make it multiply s to the power 4 plus 6 s cubed plus 11 s squared plus 6s. divided by 1 plus this full parameter. So eventually after simplification, this 200 will be just added there. So basically 200 divided by s to the power 4 plus 6s cubed plus 11 s squared plus 6s plus 12. Now we have our table, sorry, the characteristic equation. So s to the power 4, s cubed, s squared, s to the power 1, s to the power 0. Now this fill up the table. So basically 1, 6, 11, 6, 200. 6 can be divided. The common factor is there. So okay. Now 11 minus 1 is 10 divided by 1. So basically here. Then 200 because 0 here, so 200 becoming here. Again, as you can see, there is a multiplicity of 10, so basically 1, this is 20. So now, again, 1 minus 20, that is minus 19. And then 0 is here, then 20 becoming there. So now, as you can see, there is 2 sign change. So unstable, the system is unstable, and because of 2 pole in the right hand plane. Very simple example. Now, example 6.7. Example 6.7. So in the example 6.7, again, negative feedback system is provided with this corresponding for k for transfer function, that is 1 by s into 2 s to the power 4 plus 3s cubed plus 2s squared plus 3s plus 2. Okay, now again, I'm just not writing this equations. So it's better to write because we have time limitation. So we're going to write the equation derivative. So basically, yes, very good. Only this one will be added with that one if we find out that g of s by 1 plus g of s. So it will give us something like this 1 by 2 s to the power 5 plus 3s to the power 4 plus 2s cubed plus 3s squared plus 2s plus 1. Now, we already have our characteristic equation s to the power 5, s to the power 4, s cubed, s squared, s to the power 1, s to the power 0. Okay. So from the table quickly, 2, 3, 2, 3, 2, 1. So 2, 3, 2, 3, 6 minus 6. So basically 0. Then we have 6 minus 2. That is 4. 4 by 3. So 4 by 3. Now the problem is first row is 0. So you know what we have to do. Either we have to assume to the epsilon, or we have to reverse the order of the coefficients of the characteristic equation. So if this is the case, then it is 3e minus 4 divided by 3 epsilon minus 4 divided by epsilon. And since 0 is here, so 1 will be coming here. Now, what do you have to multiply with 3 epsilon minus 4 by epsilon into 4 by 3 divided by 3 epsilon minus 4 by epsilon. So basically, what will happen is, one thing we missed is minus epsilon. Okay, so what if after simplification, what we are going to get is 12, because 3 into 4 is 12, then 16. So 12 epsilon minus 16 minus 3 into epsilon is 3 epsilon squared divided by 3 will multiply with the denominator as well. So 9 epsilon minus 2. Okay, so 0 will be coming here, 1 will be coming here. Okay, now again, same procedure. Epsilon procedure. This time I'm just making things simpler here. So on this side, epsilon equal to 0 plus, epsilon equal to 0 minus. So let's check magnitude. The first one is plus, second one is plus in both cases. So let's do the plus first. Epsilon is plus, so plus. The next one is minus divided by, because this parameter is very small, so cancel. This is very small, this is very small, this is very small. So what we can find out, minus 4 divided by some plus number, so it will give a negative sign. And here, it doesn't make any difference with the epsilon. It's minus 16 minus 12, so it is plus. And last one is also plus. So there is two sign changes. Here as well. If we take the negative, then epsilon itself is negative, so negative here. Now, negative 4 divided by negative some number, so it will be plus. The other one is plus plus. So again, two sentences. So whatever you do, whether 0 plus or 0 minus, giving you the same result. Now, this is an interesting problem. So that is why let us also go for the change of the coefficients. Okay, so change of the coefficient is basically will be I start with s to the power 5. So we have to take this coefficient first, s to the power 5 and plus 2, s to the power 4 plus 3, s cubed plus 2, s squared plus 3, s plus 2. Okay, s to the power 5, s to the power 4, s cubed, s squared, s to the power 1, and then s to the power 0. Now, there's the coefficients. So basically, okay. So 1, 2, 3, 2, 3, 2. Now, 6 minus 2, that is 4 divided by 6 minus 2, that is 4 divided by 2, that is 2. And then you have 6, again, same thing, so 2 by 2. So if you want, you can divide by 1. Or now, as you can see, 4 minus 4 will actually give you 0. So 0 is appearing again. And then this 2 will become here. So 2. So as you can see, it doesn't make any difference which side you go. It always gives you the 0 in the first column. So that is why actually, without changing the order of the coefficients, is always better to go for the epsilon. Okay, so now it will be 2 epsilon minus 4 divided by epsilon. Then the 2 will be coming here. So it's a bit simpler than the first one. So epsilon equal to 0 plus, epsilon equal to 0 minus. So what will happen is first one plus, epsilon is itself plus. So now here you will have this parameter will be vanished. So basically, because the quantity is very small, so minus 4 by plus number, so basically minus and plus again. So there is two sign change again, same as the before, whatever the result you have obtained. Similarly, here we have plus plus plus, then epsilon itself is minus, then this is minus by minus is plus and plus. So again, two sign change. So I think without changing the order of the coefficient, it's better to go with the 0 plus 0 minus epsilon convention. Now the next example is example 6.8. Now we have a very big transfer function. So I'm just writing the simplified version of this one. Ts equal to 128 by s to the power 8 plus 3 s to the power 7 plus 10 s to the power 6 plus 24 s to the power 5 plus 48 s to the power 4 plus 96 s cubed plus 128 s squared plus 192 s plus 128. Very big number, a very higher order polynomial. So let us start from the table. So s to the power 8, s to the power 7, s to the power 6, s to the power 5, s to the power 4, s cube, s square, s to the power 1, s to the power 0. Now, okay, let us from the table, now it is 1, 3, 10, 24, 48, 96, 96, then we have 128, 192, 128. So as you can see, the second row can be divided by 3. So this is 1, 8, 96 is divided by 3 is 32. Then we have 64. Okay, so 10 minus 8, that will give us 2 divided by 1. Then 48 minus 32 is basically 16. Okay, 16. Then we have 128 minus 64, that is 64. Okay, 0 is here, so 128 will be here. Now, as you can see, 2 divided by 2, so 1, then you have 8, then you have 42, then you have 64. So as you can see, both the row is same, so it is going to give us 0, 0, 0, 0. So basically here we have to form the auxiliary polynomial. Sometimes it is also called auxiliary polynomial or even polynomial. P of s equal to s to the power 6 plus 8s to the power 4 plus 32 s squared plus 64. So now dps by ds equal to 6 s to the power 5 plus 32 s cubed plus 64s plus 0. So now 6, sorry. Now we have 6, then 32, then we have 64, and then we have 0. Now again, as you can see, this can be further divided by 2, so we will 3, then it is 16, then it is 32. Okay, so 3 into 8 is 24 minus 8, so 16 is 8 by 3. Then you have 3 into 32, 96 minus 32, that is 64, 64 by 3. And then you have the last one, the 64 will just come here, so 64. So now this row can be multiplied by 3 and divided by 8. If you do that, this one is becoming 1, this one is becoming 8, and this one is becoming 24. So now 16. Okay, so 16 minus 24 divided is minus 8. Minus 8 by 1 is minus 8. Then 34 minus basically 72, that is minus 40. Okay, and 0 because we have 0 there. Okay, now as you can see, there is minus 8 can be taken from, but one thing we have to be careful, we cannot multiply or the equation by minus, because then the sign will be changed. So only the magnitude can be reduced, so we change it minus 1, and this is minus 5. So what we have here is now minus 8 plus 5, so this is really minus 3 divided by minus 1 is 3. And then this 24 will be coming here. Okay, so this is 1, and this is 8. Now, again, minus 5 plus 8, that is 3. Okay, then 0, then 8 is coming here. So now there is 2 portion again. So from the even polynomial and downwards, and upper polynomial. Okay. So let us find out the scenario. So again, locations. So right of plane, left of plane, geometry axis. And then you have even polynomial, even, and other, and total. So in the even polynomial, you have 6 pole, in the other, you have 2 pole. So, okay. So now let us try to find out. So in the, is there any sign change in the other portion of the equation? So both of them are positive. So both of them are on the left of them. So there is no, now you have 6 of them. Okay. So, but there is, um, how many sign change? Is 2 sign change. 2 sign change means 2 of them is in the right of plane. Okay, so 2 of them in the right of plane, it automatically implies that the other 2 has to be also in the left of plane. Why? Because 2 of them right of plane can be the case of 2 this case or 1 this case. So in either way, so 2 of them in the right of plane and 2 of them will be in the left of plane. Okay? So this is the case. And what about the other 4? Other 4, because there is no other sentence, other 4 has to be on the geometry axis. So basically 2, 4, okay, so sorry, 6 of them. So other 2 is here. So, okay, so this is the total number. Okay, so this is how we have to figure out which approximately which zone, not in exact location, are there. So this is the way of doing the thing. And now, finally, one interesting thing is figuring out uh, the range of the stability or stability design where the root is. How can you go for that one? So I forgot the example number, but he said 6.8, something like that. So we have something like this unity feedback system. K S S plus 7, S plus 11. Okay. Unity feedback system. Okay. Now this K is given and K is assumed to be positive, and we have to find out the ranges of K for which the system is stable or unstable or marginally stable. Okay, so basically left of plane, all the poles in the right of plane, or the poles geometry axis. So let us look at this particular case. So basically, if you multiply the denominator, it will be s square plus 18 is plus 77 into s, so the whole thing into s. So basically, s cube plus 18 s square plus 77s by k. This is your forward gain. Now with that one, we have also feedback. So a simple formula, just the denominator will be multiplied by k. Sorry, added. So k by s cube plus 18s square plus 77s plus k. Okay, so this one is just this will coming from this formula, gs by 1 plus g plus. Okay, now a simple example. So basically s cube s square s to the power 1 is to the power 0. So coefficients are basically 1, 18, 77, and k. So basically 18 into 77, that is 1386 minus k by 18, and then k will be directly coming here. So basically for the stable system, all the column has to be positive. So the condition for the stability is that 1386 minus k has to be actually greater than 0. What does it mean? The value of the k has to be lesser than 1386. Okay, so this is the condition. Also, from the last one, k value has to be also be greater than 0. So otherwise, the last one will be 0, rather than being positive. So this is your condition for a stable system. Okay, so for the unstable, what you have to have? Very simple. If the value of the k is greater than 1386, on that case, this quantity is becoming negative, so there is a sign change. So your system will become unstable because of the two sign change. So basically 2 poles. So this is the condition for unstable system. And finally, if you have if you want to find out the marginally stable case, that is only possible with even polynomial. So for that, we need the entire row to be 0. So this row can be assumed 0. So if that can be assumed 0, that means k equal to 1386 is the condition for the system to be marginally stable. Okay, so the system will be marginally stable. Now, the condition here is for the marginally stable system as well. If you want to find out what should be your location of the geometric axis, you can also figure out from the auxiliary plane. So once you have the entire row 0, the equation before that row before that we have to form the auxiliary equation. So P is equal to 18 s square plus 31386. So now from this one, you can set this equal to 0. Then what we are going to get is s square equal to minus 1386 86 divided by 18. So basically s will be given plus minus j, this quantity whatever it comes. So this is the location on the geometry axis. Okay, so I think majority of the thing has been covered, except that one factor that we haven't discussed is using the even polynomial. You can also actually can find out the rest of the poles, which is actually the what we call which is called factorizing. So using that one as a factor, we can actually find out the rest of the poles location. So like look at this example here. Maybe you can apply the equation for this particular equation. We will find out the auxiliary equation. So this particular case s to the power s to the power 8. Even though it will not actually help if we try to find out factorizing this one, it will not help because of the fact that the other polynomial will be also s to the power 4. So 2s to the power 4 polynomial multiplication of that will actually give us the s to the power 8 equation. So that is why even though you can factorize this one, but this will not give us a very good result. Rather, we can actually apply it here, even though it will be simpler, but it will make us easily figure out. So s to the power 5 plus 7 s to the power 4 plus 6 s cubed plus 42 s squared plus 8s plus 56. So if you want to find out the other pole, then you can just factor it out. So even polynomial is this one, s to the power 4 plus 6 s is 4 plus 8. So if you just multiply this equation by s, Then we have s to the power 5 plus 6s cubed plus 8s. Okay, so now I have 7s to the power 4 plus 42 s square plus 56. Now multiply by 7. So 7 is to the power 4 plus 42 s square plus 56. So as you can see, the other pole is easily figured out. So using this even polynomial. So this factorizing can also be done even with larger examples that we have seen. I think the last example of this chapter is based on that one. So we just will advise you to have a go about this one. So that will help us for a smaller polynomial to figure out the location of the pole. Okay, so this is the end of chapter 6. Hopefully this will also be the syllabus of your midterm examination.